Hello everyone, this is Bhanupriya, research scholar doing research under the guidance of Dr. Sabita Gauni, Associate Professor, Department of ECE, SRMIST, KTR, Chennai, India. Today, I am going to discuss about my research topic, a novel deep learning model-based data offloading for autonomous electric vehicle networks with blockchain technology. Let's see in detail about data offloading. The presentation flow is as follows: introduction, offloading at the edge, challenges, related works to my field, objectives of my research, acronyms used, vehicle attributes, the complete description of the research topic, conclusion, and the references used. Let's see in detail. Let's move on to the introduction. We're going to see about autonomous vehicle. Autonomous vehicle has gained a lot of importance in recent years because of its varied and services offered on its wheels. A guaranteed performance, safety through intensive sensing from the various sensors on the vehicle are the advantages of autonomous vehicle. Since there are various sensors involved in autonomous vehicle, huge amount of data has to be processed. Management of this massive amount of data is a very big challenge for an autonomous vehicle that, as you know, is a driverless. And quality of service has to be provided without latency, and the throughput has to be higher. And also, since the data has to be processed either in the vehicle and the cloud and the edge computing, the environment is keep on changing. We call it as an heterogeneous environment, which is a high challenge for an autonomous vehicle. The processed data in autonomous vehicle might be hard real-time data. What is hard real-time data? When data has to be processed in real time, immediately, without any delay of even a millisecond or microsecond or nanosecond, it is said to be hard real-time data. For examples, emergencies involving accidents, surgeries, or the path where the autonomous vehicle is going, the decision has to be made is said to be hard real-time data. Soft real-time data is not an immediate processed data. It might be audio video streaming services or some other services that doesn't involve immediate intervention. Non-real-time data are the data that could be processed anytime. For example, email services. So these are some of the data categories that are processed in an autonomous vehicle. So when you see about the autonomous driving model, it involves the sensors, the perception of the data, where it has to be localized, object recognition when it is traveling, object tracking, and based on the perception, the decision has to be made by prediction, path planning, obstacle avoidance, and The data can be processed either in cloud platform or edge platform, and finally it is stored. Yes. So since there are so many sensors, the challenge of using an autonomous vehicle is quality of service requirement with low or ultra low latency, and this challenge can be overcome by using in mobile edge computing. Edge computing is nothing but providing services at the edge or nearby vehicles. Since this involves mostly vehicles, we call it as vehicular edge computing network. Point-to-point computation, high storage, increased bandwidth, and wide range of computational units are high advantage of an autonomous vehicle. So to process the data in an autonomous vehicle, the architecture involves the smart onboard unit, we call it as SOBU, MEC server, the mobile edge computing server, and the interconnected cloud network. The processing unit, memory, vehicular controller, GPS receiver model, and interface unit present in the smart onboard unit basically helps in communication of a vehicle with the heterogeneous environment, which might be the edge servers or the roadside unit or the cloud server. So the smart onboard unit SOBU is mainly involved in the complete vehicular communication. The research objective of our model is to analyze and observe vehicular networks and to design a framework for transferring the data securely in vehicular networks. So here the framework has been designed. Then, to classify and test the vehicle computational parameters using deep learning algorithm and to provide the required computation capacity. So in detail, we'll be seeing how the vehicles are clustered together, then classified according to the vehicle parameters. Then we'll be checking whether the prescribed model or the proposed model is better than the previous existing model. So some of the vehicle attributes for my research are frame ID, vehicle ID, bounded width, bounded height, perimeter, speed, and density of the vehicle flow. Yeah. So what is frame ID? So when vehicles are moving, the images of the vehicle are captured in a frame, and each vehicle has been given an ID in order to track it. So within the frame, the bounded width and bounded height of the vehicle has been calculated. Since the vehicles are moving at certain speed, the speed could be calculated using the mean speed formula, and the density of the vehicles per meter has been given by N by L. And where N is nothing but the number of vehicles and L is nothing but the length of the road in the frame mentioned. And vehicle flow is given by F is equal to N by T, where N is nothing but the vehicles and T is nothing but the time period or the duration in which the vehicle has been going. So these are some of the vehicle attributes that has been considered for doing my research. So uh, first of all, when we are going to see about the uh, analyzing the vehicle parameters, the vehicles are clustered together. How are the vehicles clustered together? By group formation. In group formation, the common features are considered and the vehicles are clustered together. So for clustering of vehicle, the k-means algorithm has been used, where k involves the number of clusters. So if k is equal to 2, the number of clusters has been considered to be 2. And the previous challenge of k-means algorithm is that the allocation of data point was difficult, and to overcome this, cosine similarity distance algorithm has been proposed, wherein the distance between the centroid and the vehicles has been reduced as small as possible. Cluster head. Cluster head is nothing but inside the clustering there has to be a common vehicle that can communicate with the other centroids or with the edge servers. So that is said to be the cluster head, and node with the highest energy, lower distance to the base station, and other nodes are chosen as the cluster head. Mobile edge computing server selection. So based on the number of vehicles and based on the requirement, we are selecting the mobile edge computing server, and deep learning approach has been used for the selection. While selecting the mobile edge computing server, the scheduling of vehicle has to be done through roadside unit, and data offloading depends on memory, speed, cost, bandwidth, disk management, energy consumption of MEC. What is data offloading? So like whenever there is a communication of an autonomous vehicle between the edge servers and the cloud servers, there will be always the internet that is not consistent. So whenever there is a lag in internet, the edge server or the cloud server has to be selected accordingly, so that there should be zero latency that has to be achieved. So that is data offloading. Offloading, there are two kinds, basically data offloading and task offloading. Here we are going to see about only data offloading as of now in my research. The vanishing gradient problem of the normal deep learning approach has been overcome using ReLU activation, so that the back propagation delay of the deep neural network has been overcome. So, after clustering of the vehicle, mobile edge computing servers are selected, and after that, resources has been allocated. Resource allocation in the sense, like in the chicken swarm optimization, helps and allows an agent to learn an optimal vehicle scheduling policy. The scheduling process is done, and the task is according to the task requirement. The resources are allocated to every system. The best of actions is exploited in order to maximize the long-term resource allocation needs, minimizing costs, and also uh, satisfying the request from the server. The computation of vehicle weights is based on vehicle parameters. So the complete proposed framework is as follows. So first of all, we have done the clustering of vehicle, and after that cluster head has been selected. Then the mobile edge computing server has been selected. Resource allocation is done. After resource allocation, we are planning to involve blockchain technology for vehicle security. So the computational parameters that has been measured here are clustering time analysis, clustering findings, performance metric, local processing time, and average response time. Yeah. So based on the proposed model, some of the results we are going to see are clustering time analysis. So we saw clustering is nothing but grouping of vehicles based on their vehicle parameters, common vehicle parameters. So some of the other algorithms has been considered, analyzed, like FCM algorithm, KMA algorithm, and the proposed chicken swarm k-means algorithm. And we could see that the proposed algorithm has a lesser clustering time compared to the other algorithm. The time slots for this analysis involves 100, and the roadside radio range is 1000 meters. The complete range has been considered as 1000 meter, while the communication happens between 300 meters. The vehicle speeds will be around 1 meter per second, and within the range 1 meter per second to 2.5 meter per second, and the vehicle processing rate is 10 cycles per second. So these are task size in terms of megabytes and task requirement in terms of cycles per task. So the clustering analysis shows that clustering time for the vehicles in the range between 100 to 500 The, the proposed algorithm has the least clustering time of 2.85 milliseconds, while for the clustering of 200, 300, 400 and 500 vehicles, the clustering time is 4.25 milliseconds, 5.82 milliseconds, 6.58 milliseconds, and 7.89 milliseconds respectively, which is lower than the existing algorithm. The performance achieved. So the comparison of the proposed deep learning network with the existing algorithm based on the parameters precision, recall, F-score and accuracy shows that the proposed algorithm has a higher value of precision, recall, F-score and accuracy from the observed data. So the performance metrics where we consider precision. What is precision? How many vehicles are selected that are relevant? How many relevant selected is said to be recall. F-score is nothing but weighted average of precision and recall. And accuracy is the fraction of prediction that the model is correct. So the prediction formula is given by this formula, and accuracy is given by true positive plus true negative divided by true positive plus false positive. So based on true positive values and true negative, true positive, true false positive and false negative values, the F-score has been calculated. So based on these values, the performance metrics shows that the proposed model has an accuracy of 96%, which is higher than the other algorithm mentioned previously. Average response time. Average response time is the response time of the service when a task has been requested by the vehicle. The average response time of tasks increases as the task requirement increases, and the lowest response time is for the proposed algorithm compared to the other algorithm. So when the task count was 400, the response time achieved was 8.6 milliseconds, which is lesser than the previous existing algorithm. So the graph also shows the same. Local processing time. Local processing time in the sense when a task is required to be done by a vehicle, if based on the priority, if it has to be processed locally by an edge server, the processing time has to be lesser. This has been shown in the graph. Blockchain technology. So the framework has been proposed, and after the framework proposal, some of the research findings we have been discussing. So in future, we are planning to use a blockchain technology, since the recording of information is such that it is difficult or impossible to change by anyone. So here the blockchain technology we are planning to use for storing of information of data, vehicle data securely. The registry stores all the information about vehicles from start till the latest. The distributed storage of records is arranged in a chronological order and decentralized, and it is decentralized and cannot be hacked. So based on the discussion or description of my research, we could see that the velocity and the number of vehicles are continuously monitored here, and hence the collision and accidents between vehicles could be avoided. The accuracy obtained by the performance metric is 95.69, so which is better than the other previous models available. And since there are a number of attributes and combination of different algorithm has been used, this model definitely will work under a heterogeneous environment. And these are my references for my consideration so far. Yeah. And in future, we are planning for um, using this model with some of the computational attacks or vulnerable attacks like brute force algorithm attack and 51% algorithm attack and denial of service attacks. So some of the attacks will be given for this model, and how it could be shielded will be the future work of my research objective. Thank you for listening, and for any queries you can approach me.